after all these videos, now let's see what we have. We have the definition of a real number set. That means we have set of real numbers, and then we also defined order on that set R. Alright. So after order, what is the most common obvious thing, or what we did after definition of order? We went for what are upper bounds and what are lower bounds, isn't it? And for our definition of upper bound and lower bound, those are elements of the set. Here, since our set is R, our upper bounds are also numbers. Numbers means I'm talking about real numbers, okay? Real numbers. When lower bound are also numbers, okay? Uh, let's say we have a set A, okay? Which is not a null set, okay? For with null set, we cannot talk about upper bound and lower bound, and which is a subset of real numbers. Fine. Let's say it has upper bound. Then let us look that upper bound in terms of cut. Okay. So let beta be an upper bound. An upper bound of A with respect to R. Okay. What is beta? This is a real number, right? So there must be a cut also, because we are looking every real number as cut. What are cuts? These are subsets of real rational numbers. Subsets of rational numbers, and we have a video about those things. What are the properties and all those things, right? So we have this much. Okay, so this with this beta, there is a corresponding cut. Let us call that one also beta. We used to do these things, right? We used to think whenever we need a number, we will look it merely as a number. Whenever we need properties of the set, we will shift it as a cut. So let's shift it as a cut. So there is a beta, and what A also has numbers, right? So A must all these numbers, okay, not okay, all these numbers must be some cut, okay. If beta is the upper bound, beta should be greatest number than all these numbers of the A. So all the cuts of the A should be proper subsets of the beta, isn't it? Because when we say a number is less than the other number, cut corresponding to the lesser number should be proper subset of cut corresponding to the greatest number. So here what we have is this one. We have alpha is less than beta for all alpha belongs to A. That means alpha belongs to A means there is a uh, cut, say alpha, whose corresponding number is in A. You can look it like this. Okay, there is a number, say alpha. This is a number. Sorry, there is a cut. There is a cut, say alpha, whose corresponding, okay, whose corresponding number is in A. So this means alpha belongs to A. Alright. So this is how we are going to define upper bounds. Similarly, lower bound. Let's say, let's say this gamma is the lower bound. What are lower bounds? Lower bounds are the numbers. Those numbers should be less than every number of a. So our gamma is such a kind of cut which is the proper subset of uh, you you must take a note that we are using the Rudin the thing that we are instead of using this symbol for the proper subset, we are using this less than symbol. Okay, because ultimately we have to stick with the Rudin since we are going with the Rudin. So gamma should be the proper subset of every cuts belongs to A. So this is how we are going to define the upper bounds, okay, and lower bounds.